Hello, in today's lesson we're going to learn how to work with a function that is defined algebraically. In the previous lessons we talked about the fact that a function can be written in the following form. We can write down a functional relationship when we write f from x or g from x or h from x. And there can be an infinite number of these entries. Why? The point is that these letters, they're arbitrary. We define arbitrary letters. If we're talking about the dependence of the perimeter of a square on its side, I can write that with other letters. The perimeter depends on the side of the square. But I can write that dependence in a different way. I can write it as f on x. So that shows that one variable is in a relationship with another variable. And that relationship is a functional relationship. And so if you see a statement like this, f of x equals 2x minus 5, then we can say that this function is defined algebraically with a formula. I can express this notation expressed as follows. Y equals 2x minus 5. And then I also realize that if my x changes, the value of the variable y also changes. The variable y depends on the variable x, and it is a functional relationship. But it's very common in math to find assignments in which a function is given as a formula, and the value of x is given. Let's say x is equal to 5. And accordingly, we need to find the value of y. And what you need to do, to know exactly that instead of the variable x, we need to substitute a value equal to 5. And then we will find the value of y. 2 times 5 minus 5. And that equals 5. When x equals 5, then we use also 5. But in this case, you can say we're just substituting the value in place of the x variable. Yes, I agree. But this notation might look different. If I said that functional dependence is defined by writing f on x, g on x, and so on, then I can write that f on x equals 2x minus 5. That's what I mean by the functional dependence on x. And then notice the following notation. If I substitute the number 5 for x, then in the formula itself, which expresses this dependence, I must also substitute 5 for x. You need to remember, in math, if you are given an expression and the same variable is written in that expression, then the value of that variable is equal to, if the variable x is written in parentheses, and that value is 5, then in the formula itself, we substitute 5 for x. Here's that notation. The f of 5 equals 2 times 5 minus 5, and that is 5. Thus, f of 5 equals 5. If you write down f of minus 1, then instead of x, the value is minus 1. And then we will substitute that value in place of the variable x. The result would be 2 times minus 1 minus 5. And then f from minus 1 equals minus 2 minus 5 equals minus 7. Thus, this notation denotes in our relationship, if x equals minus 1, then y equals, let's write therefore, y equals minus 7. You can use such records when you work with functional dependence. But there is another kind of notation. We talked about the fact that in our function we can not only substitute some values instead of x, but also substitute values instead of y. So let's go back to our functional relationship. F from x equals 2x minus 5. And let's remember that f of x is y, equals 2x minus 5. And if we've given the value of x, we can now give the value of y. Let's say y equals 15. Then we need to find the value of x. How do we do that? Instead of y, we substitute a value equal to 15. As a result, we get 15 equals 2x minus 5. And solving this equation, we get that 15 plus 5 is 20. 20 equals 2x's. Hence, x equals 10. When e equals 15, then x equals 10. If we're talking about a functional relationship, I can think of it another way. If e is equal to 15 and e is f from x, if e is f from x, then instead of f from x, I can substitute 15. And if f of x is 15, then the value of y is 15. So instead of f of x, instead of this value, I put 15 instead of this value. And then we have 15 equals 2x minus 5. And we've already used this notation. In a functional relationship, you need to know exactly which variable you're substituting for which value. And that's what the condition of the assignment will tell you. If you have values written in parentheses, then you substitute those values in place of x. If you have a value written in place of f from x, then that is the value of y, and then you need to find x. In the next lesson, we will solve some more examples, and for today, our lesson has come to an end. Goodbye, see you again.